Hello guys, this is Ken Nash again, and we are back to do more with R. And today I want to take you people how to do correlations, and then how you can identify outliers, or how do we call it, how you can use histogram and box plot to identify your outliers. So first of all, we have to import these libraries. So if you don't have these libraries, please do how to import the packages, the ggplot2 and then the tileverse. As always, I will say come to tools. If you are a beginner, come to tools, just press on the install packages, and over here you can get to input the packages that you want to install, then you install. Okay, and after which you import, you bring in the libraries, the packages that you have downloaded or installed with this library command. Alright, now we just have to just press command or control enter to execute them. So I'll just press. You can see that down here at our console it has been executed. You can see that a library ggplot2, tidyverse, and plot that has been done. Now as always, I want to see what is inside my data. I want to use US arrest. This is data about arrest made in USA. And again, this data is inbuilt in R. If you have downloaded or if you have installed R, then this data should be found inside. Okay, so I want to use this data for my analysis today. So I always press ask, because I don't know what data is all about, so I always ask R to tell me something small about the data so that I can get to know the data I'm dealing with. So again, we go with the question mark what USA arrest. Then on our help button, it will tell us what the data is all about. You can see it over here. I'm not going to waste time on this. If you are doing it, follow me, and then you make sure you read everything to get to know what the data is all about. And also, I normally prefer viewing my data. So to view, I just use the view command, and then I'll get to know what the data is all about. So I can see the data contain meta, assault, and then urban population, and then rape. So these are the cases. These are the variables we have in here. So we have, and then they have the cities: Alaska, Arizona, California. They are those cities are our indexes. I get me. That's our indexes. So we come back here again, and then I want to make a correlation between rape, urban population, meta, and the rest. So I can just do core USA arrest because my data is numeric. It will just give it a correlation for all the variables because it's numeric. So I can just press command enter, and you can see it over here that we have the meta correlated to itself. Normally, if a variable correlates with itself, the correlation is 1%, right? 1 or 100%. But the meta with assault is very, very high, which is 0.8. There is a high correlation between meta and assault, and there is a very low correlation between urban population and the meta. You can see it from our correlations. Okay, so with the assault, you can see normally people who are assaulted end up dying, or maybe people who are murdered, maybe they normally assault them before they get murdered, or they normally beat them and all that before they finally before they finally pass away or before they finally die. So again, I want to make, because this is very, very low, the meta and the urban population is very, very low. I want to make a scatter plot to see the trend. I want to see the relationship between meta and then urban population first, because I can see it's very, very means that it's not really correlated, but I want to see it visually to see how it is. So again, I'm using ggplot. So execute your coin, and then you can see that it is not really correlated. You can see the diagram is scattered anyhow. There is no trend, so it means that it's not really correlated, right? But you can see that on our correlations, meta and urban population, meta and assault was really, really high. It was really, really correlated. So let's see, and let's look at it and see what it's going to be. So I'll press that again, and you can see that this has a very high correlation. I'm setting the color to be equal to blue. That's a very, very positive correlation. You can see our scatter start from the 0 and then it moves all the way here. It is showing a very positive correlation. It means that as meta cases increases, let's say assault increases, then meta 2 will also rise and all that. And now over here, we are trying to identify whether rape. I'm going to use rape here for my analysis to see whether how do you call it? There are some outliers in the rape, or maybe to see if it's normally distributed. So the ggplot too. I'm using that one for my analysis. So this is your command you're going to execute, and I'm setting my bins to be 25. You can change it to any number at all you want. You can change it to 30, 40, and all that, depending on the number. Bins means the bars that I want. So I'm setting the bars to be 25. So if I execute this, I have a very nice histogram plot, and you can see that it is really skewed. It's not normal distributed. So this to tell you that at least there might be some outliers in our data. There might be some outliers in our data, and I want to really see this outlier with the box plot. And ggplot again can help me get that box plot. Okay, so I'll execute this. I'm naming this my plot. So if I execute, it happens. But if I click my plot, you can see that this is my box plot, a very nice box plot here. And you can see these two numbers, these 2 points here. These 2 points here, they are outliers. These 2 points here, they are outliers. Okay, they are outliers. So this is how basically you identify outliers in our data. This is how you're going to identify outliers. So these are outliers. This is what I have for today. Please, if it is really good, please help me, like the video, subscribe for me. Okay, let's continue to impact lives. Thank you guys very much.